Hello and welcome to my presentation at this year's SAS Global Forum. Let me introduce myself first. I am Kurt Bremser. I work as a data warehouse administrator and SAS developer at Allianz Technology Austria. I work with SAS since 1998, and during my work at the company I have led the transition from mainframe SAS to Unix SAS as the first big project. I am also a super user on the SAS communities, and I am the author of the Maxims of the Maximally Efficient SAS Programmer, which are presented at SAS Global Forum 2019 in Dallas. Let's look at what we will be dealing with today. I guess that most of you will have happened this in one way or another in the past. What are the ingredients for this most unfortunate event? You have a dataset that exists in a library accessible to other users and/or processes. You need to overwrite it or create it new. And as it happens, one or more users or processes has this dataset open, for instance in a view table window or as a source in a procedure or data step. And as Murphy's Law wills it, this will happen at the most inopportune moment in a very important job leading to a call of the data center people to you at 1 a.m. in the morning. What are the possible remedies? You can define a dedicated time window during which datasets are updated. This requires you to stop all services for that time window, kill all existing processes, so you can do your work. In a modern world where you want to have 24/7 operation, this might not be a viable option. You could search for the offending process and ask the user owning it, which might even be you yourself, to stop it, to release the file, or do anything else that you can. Or you simply kill the process, which is not a very nice thing to do, as you might destroy a lot of work of other users. And after this is done, you still have to rerun the job, and then you might find out that still another process has the dataset open and you have to repeat everything all over again. Or instead of trying to rewrite the dataset as is, you delete the dataset file from the file system before you write it. This is possible because of the way a Unix file system is structured. We will now look at what's the background of this and how it is done. A Unix file system consists of three major areas: a block map, an inode table, and the data area. This is a rough outline. Modern file systems have quite more. The block map, very simple, keeps track of allocated and free blocks, nothing more. The inode table is important. It's an array of structures. That's why the inodes are called such, indexed nodes. And these structures contain all the file's metadata: the owner, the group, timestamps, permissions, the file size, and the allocated blocks. It does not contain a file name. Directories are files in the data area, and they contain the names and only inode numbers, but no more data about a file itself. The inodes themselves keep a track and account of the links pointing to them. It is possible to have more than one link pointing to a file, and in certain situations it is possible that no link exists. You may ask about the situation on Windows. Although NTFS is quite a lot developed since the old FAT file system we used in the DOS times and in the early Windows times. It is still not you still cannot remove or manipulate a directory entry while a file is in use. I have tested this, and the system's del command, even with the force flag, will not do this. What do we use? We use external commands if the xcmd system option is enabled, or the fdelete function if you do not want to use an external command. If an external command is used, it is rm-f. The force parameter prohibits any request of confirmation if you find a file, if you want to delete a file where you have no write permission on the file itself. Because to remove a file you only need write permission on the directory containing the directory entry. And a data step or macro code is used to perform the actions. Let's look at the macro code itself. It starts with a little documentation where a simple description is there what the macro is intended to do. If it is called without a parameter, a usage note is written to the log and the macro terminates. The next part, I consider this very important. Make sure that all the variables you use in a macro are defined as local, so you do not accidentally interfere with the global symbol table or with the symbol table of a macro calling your macro. A simple check is done for the validity of the dataset name. If it contains more than one dot, we reject it and terminate. Next, if we find a single level dataset name, we assume the dataset to be in the work library. Then we check if the dataset and or view, because we can use the macro for dataset and views. If it's there, we proceed. If it's not there, we issue a message and terminate the macro. Next, we determine from the type of the member what kind of file name extensions we have to use, either that one for a view or for a dataset. We also retrieve the physical path name of the library by using the path name function. Then we build the complete file name. Next, we decide which of the options the user has requested. If we want to use the external command, we build this command by using the rm-f and the path name. If the save action is requested, we simply run the command with the sysexec macro statement. Otherwise, we use a data step, a data null step with the infile pipe statement, read all the responses coming back from the operating system and write them to the SAS log. This might be handy for diagnostic purposes. If we want to use the internal SAS function fdelete, we once again have the decision if we want to use the macro code as such. We wrap all the necessary function in a %sysfunc macro function. We assign a file reference. We use this file reference in the fdelete function, and we deassign the file reference. We use a macro or pool macro statements in case we want to insert the macro call in a procedure. For instance, think of the SQL procedure where you run several queries, and in between you want to delete an existing data set without breaking the SQL procedure as such. Then you do not want to use a data step. And we always clean up after ourselves by deassigning the file reference. If we do not do this, a file reference assigned with the file name function will exist for the duration of the SAS process. If you repeat this again and again, you will clutter up your file references table. Next, we also have the option to do the same thing in the data step. In both cases, with the %put or with the put statement as such, we record the return code of the fdelete function in the SAS log. Finally, since we established a file handle on the dataset file itself, we close this so we do not keep this in the memory of our SAS process. Removing a directory entry will not remove the file as such immediately. Only when the kernel finds that no link to an inode exists and no open file handle is there, then the file will be deallocated, its blocks freed, and the inode will be removed. A user who has the dataset open will be able to work with its contents, but will always see the old contents. To see the new contents, the user has to close and reopen the dataset. In this moment, the physical data will be removed. Since it is possible that you have more than one version of the file physically present in your file system, this might cause extensive use of storage. Imagine that you use this process again and again and again, and unfortunately every time somebody starts to look at the dataset and does not close the view tables. So you might have an arbitrary number of versions of your dataset physically present, although you can access only the newest version. It might be that you run out of disk space. It has an additional benefit and side effect. Since you work only on the directory and the permissions on the file itself are not really relevant, it is possible that you overwrite a dataset created by another user. With the default UMask of a Unix system, you cannot write on files created by another user because only the user themselves will have write permission. This macro enables you to do exactly that. So this is very advantageous if you have to work with a shared library where multiple users are permitted to create datasets. It has limitations. You cannot append in place. If you need to do an append, you have to copy the existing dataset to your work, do the append there, remove the existing dataset and copy the new dataset to the location. Index files are not removed. This is intentionally not done because when you write a dataset and SAS finds an orphaned index file with the same name, this index file will automatically be removed. Since the macro is intended to be used immediately before writing a new dataset, I do not remove possible index files. It is not intended to be used on datasets with generations, and you need to take care in case you work with data on a network share. It might be that the network file server does not support all the Unix features necessary for this to work. If you want to learn more about the Unix file system and the inode, I have included the web pages on Wikipedia for these two things. If you run my macro, if you encounter problems or you find a useful improvement, feel free to comment on the SAS Communities article about this macro. And if you want to contact me personally, please log on to the SAS Communities, navigate to my profile page and send me a personal message. I hope that this was interesting and that you can make use of the macro. Thank you for listening in and goodbye.